me share. Keep in mind too, our base units, right? Because we can always go back to the base units. If we're in a particular unit, we can always go back to the base. So when we want to go from as in B, meters to centimeters, right? We can do that. It says it gives us 8.160 meters. And we want to know how many centimeters is that. What do we need to know to solve this problem? We need to know what the unit centimeters mean. So what does centi mean? Anybody?
A 100.
Is it 100 or 100th with a th on the end? You're right. It is 100. Yes, it's 1 over 100 or 10 to the minus 2. All right. So if I want to convert meters into centimeters, I need to do this. I need 8. This is my conversion factor, 8.160 meters times 100. I can do 100 centimeters over 1 meter, or I can do 1 centimeter over 10 to the minus 2, or let's say 1 times 10 to the minus 2 meters. I can do either one, right? Because both are the same. It's 100 centimeters for every meter, or I can put this, but I in both, notice in both calculations though, I need centimeters in the top, because in the top, that's my desired unit, and in the bottom is my discarded unit. I'm trying to get rid of meters. Either way, I have centimeters in the top. So I can have 100 centimeters over 1 meter, or 1 centimeter over 1 times 10 to the minus 2 meters. All right, are we okay with that? Either one of those conversion factors will be fine. And it's up to you which one you want to use, because they're both equivalent. All right. Notice another thing. So I'm going from a larger unit to a smaller unit. Normally, that means my number is going to get bigger. All right. So my number is going to get bigger and not smaller. So let's calculate that out. So let's use this one. All right. So 8.160 meters. The meters is going to cancel. That's going to be 8.160 times 100. Somebody give me that number. Is that right?
Yes.
816 centimeters. And this is a multiplication and division operation. How many sig-figs are here? Say that again. Remember, Pacific method is for decimal points. Atlantic method, no decimal. So we got a decimal point. So we come on here. First non-zero digit. Anything after that is significant. So what do you think?
4.
4 sig-figs. How can we write this number with 4 sig-figs? Right, we don't want to use scientific notation, but we can do something else to that number to make it 4 sig-figs too. What would you do?
816.0.
You can add the 0.0, the decimal, 816.0 centimeters. Very good. Who was that?
Calvin.
Excellent. Nice work. Right, now we got 4 sig-figs. Are y'all following? Anybody have a question about that? Because again, we're trying to combine all these operations instead of me just walking you down and teaching you checking off a box, which would take us until the end of the semester. Now we can start combining some concepts. So we know our units, we know our base units, we know what the prefixes mean. Go ahead, Saxton.
So, okay, so we wanted 4 sig-figs over there from 8.160. We were trying to get, what was the point of us getting the 4 sig-figs?
You know what? You're right. You're right. if it is a multiplication and division, we want the least number of sig-figs. Is that right?
Right.
You're right. You're right. I apologize for that. So we have how many? What's the least number? Both of these numbers right here have what? 1?
Yes.
Yeah. The 100, the zeros are trailing. So
Mm,
that's 1 sig-fig, and we got 1 in the bottom. So that's 1 sig-fig. It's an exact number. So let's do this then. You're right. And thank you for catching that. So this is 816 centimeters. So actually, I do want this in scientific notation. So I'm gonna move that decimal place over. 1, 2. Come on, Russell. Tighten up. 1, 2 here. So that's gonna be 8.16 times what?
10.
Excuse me.
Yeah.
Centimeters. Is that right?
Yes, sir. That's
And
right.
now this is gonna round that up. So that would be 8.2 times 10 to the second. Thank you for catching that, Saxton. Centimeters. And then this is gonna cause that to stay the same. So now it'll be 8 times 10 to the second centimeters. All right. Any questions about that? Because it's a multiplication problem, I want the least number of sig-figs in the answer. It becomes, what happens as I decrease the number of significant figures? What happens to the number itself? Does it become more uncertain or less uncertain? All right,
Lessons.
it actually becomes more uncertain, because when we look at this number, what is this number roughly? This is 800. Is that right? And when we compare that to this number, there's more uncertainty here. I'm gonna give you a perfect example. If your rent was 816 and you took them $800, what are they gonna tell you in the rent office?
It's not enough.
Not enough, right? You're off by $16. So the less sig-figs you have, the more uncertainty you introduce into a number or a calculation, right? The more sig-figs you have, the more certain the number is, right? So let me write that down over here. I'm abbreviating sig-figs now, so don't panic on that. That's my abbreviation for sig-figs. So less sig-figs is more uncertainty. When you start rounding, you start making that number more and more uncertain instead of more precise. So more sig-figs equals less uncertainty. That number is more accurate and is more precise. So less accuracy, the less numbers you have to work with in a calculation, the less accurate the calculation is. The more numbers you're working with, the more accurate it is. But what you don't want to do is start rounding before you get to the answer. You want to round the answer itself, not before you get to it, because that creates uncertainty with the numbers that you're actually doing the calculation with. So all the rounding and all that stuff happens after the calculation. All right. Let's do another one. Which one y'all want to do? Y'all want to do we do micrograms to grams already? If you have your handout, which ones of these have we completed?
I think we did the micrograms to gram. I don't have my handout out, but I can go look.
I think we did that one. Let's do what we got other ones to do. Let's do D, milliliters to liters, because again, this is practice. We're tying in sig-figs, units, prefixes, all of that stuff, all at the same, and conversion factors, all at the same time. All right. So we're doing what is it? 781 milliliters to liters. All right. So what I want you to notice first is you're going from a smaller unit to a larger unit. So that number is going to decrease. So when you go from a smaller unit to a larger unit, your number, your value is going to go down, right? If you go from a smaller unit, I'm sorry, a larger unit to a smaller unit, the value is going to go up. All right. So let's look at it. What is the base unit here? What's my base unit?
Leader.
Liters, right? That's what I'm working with. So all of my conversions are going to be centered around that. And what does the M in front of the liter, the milli prefix mean? Anybody?
It's 1,000th.
1,000th, good. 1 over 1,000 or 1 times 10 to the minus 3. Right? That's what the milli prefix tells me. All right, so let's do that conversion. All right. So I'm taking 781 milliliters. And I'm trying to get to liters now. So I want liters in the top. 1 liter over 1,000 milliliters. All right. The reason I'm using that is because sometimes if you're not used to putting those negative exponents into your calculator and putting the parentheses and all that stuff, it's easier just to put the number in. All right. So 1,000 milliliters is equal to 1 liter. So milliliters will cancel and I'm left with liters. Again, this is a conversions, sig-figs, units, prefixes. We can always go back to the base units. And anytime you're converting between units, even if you have 2 units with prefixes, you can go unit, base, and then base to the next unit. Anytime you want to do that, all right, that makes it much simpler operation. All right, so what do we have? 781 divided by 1,000, that's going to be 0.781. Is that right? Liters. Yes, no?
Yes.
Yes.
All right, and then we can take that and simplify it down to 0.8 liters, which is how many sig-figs? And 0.8 liters.
One.
1 sig-fig. Pacific method from your first non-zero digit after the decimal is 8. So it's 1 sig-fig, which is what we want, right? Because this is 1 sig-fig, this is 1 sig-fig, and this is 3 sig-figs. But because it's a multiplication operation or division operation, we want to keep the lowest number of sig-figs, so it's 0.8. You see the uncertainty there, right? If we say if it's 0.8 liters, but it's actually 0.781, that's a big difference, isn't it? All right, so this number becomes, again, more uncertain than the original number once we start rounding and all that stuff. Let's do another one. Let's do, all right, so if we done liters to milliliters, then that means that you can handle the other conversion. We're gonna do one of each. Let's go did we do kilograms to grams already? This one, E? I know it's highlighted, but I can't remember if we did it or not. We may not have gotten to it. So let's do that. 4.18 kilograms. How many grams, right? What does the kilo stand for? That prefix.
1,000.
1,000, right? Or 1 times 10 to the third. So if it's a kilogram, that means that that's 1 kilogram is equal to 1,000 grams. So that's our conversion. All right. So we can make that again, set the conversion factor up. What goes in the top? Go ahead, Saxton.
Grams goes on the top, but I was trying to figure out which ones are the hundreds because I'm getting them mixed up. Which one me?
100 is centi is 100th, and we don't have uh, a prefix for 100, right?
Oh,
We go actually from grams to kilograms. I want to say it's Deca, DECA, but I don't want to say that on this recording. No, I'm just joking.
yes,
I already said it. Now I think it's Deca.
uh-huh.
I know. I'm just
I'm
messing.
gonna look it up.
I,
We gonna figure it out. We can get us a chart going.
well, we got a chart. I gave y'all a chart. The 100 just wasn't on there.
Okay, got you. Got you.
One decagram. Yeah, I think Deca is actually Deca is 10. Just like Deci is let me see. Look it up. Nothing like that. Hecto. It's actually a hectogram. But that's not a common, like it's not a common prefix. But hecto is 100. But we didn't have that on our chart. It went we had micro, femto, pico, milli, and then it went centi, and then grams, and then it went straight to kilograms. But the 100 is a hectogram. But we're not gonna worry about that. But for the information purposes, that's what 100 is. And I'll put it there. Is that cool?
Yes,
And I'm
sir.
still putting that on YouTube because I don't care. I said Deca at first, but Deca is 10 and then Hecto is 100. But I really don't care. I had some dude come for me on one of my other videos. It was a video I made for my class. He was going all in. Yeah, we had to choose violence that day. So
Huh?
sad. So sad. So 1,000 grams over 1 kilogram. So kilograms is going to cancel. Again, going from a larger unit to a smaller unit, you expect that number to get bigger. What do we have? 4,180 grams. Is that right?
Yes, sir.
And that's 3 sig-figs. We want 1 sig-fig. So we're going to do this. We're going to say that this number is 4 times 10 to the third grams. All right. Because if we take this, move the decimal 3 times here, that's going to give us 4.18, which is going to round to 4.2, not 42, which will give us, which will round to 4, right? Times 10 to the third grams. Again, it's more uncertain if you got if you owe $4,180 on your car and you only give them 4,000, they're gonna come after you and mess your credit up. All right, let's do I, because I think we've done meters to kilometers already. So this you can do on your own. Let's do I. Yeah, H you can do on your own because we've done that. Let's do I. 1.9 gigagrams to grams. What do you think? What is giga anyway? Anybody? If you have that chart that I gave you the other day, feel free to use it.
Is it a billion?
It's a billion. 1 times 10 to the 9th giga. So giga, that prefix is 1 times 10 to the 9th or 1 billion. big number to a smaller number, what does that mean? How many grams is that going to be? The number is going to increase, right? Because you're going from a larger unit to a smaller unit. So you can say 1.9 gigagrams equals or times what? What's my conversion factor? 1 billion grams. I'm gonna keep the units over 1 gigagram. Or we can also put this in scientific notation, 1 times 10 to the 9 grams over 1 gigagram. Either way, it's going to be a huge number in the product that we're going to have to simplify down. All right. So what is that going to be? The gigagrams will cancel, but everything is 1, right? So it'll be 1.9 times 10 to the what? 9th grams. Is that right? Yes, no, maybe.
Yeah, I got the same thing.
Yeah, one. Hold on, let me recount. Yeah, I think so. I think you're right. I think you're right. I'm gonna trust you.
Thank you for your trust in me. And then I can take that and I just round it, right? To 2 times 10 to the 9th grams for sig-fig purposes. All right. All right, let's go to some more, a little bit more challenging calculations. Let me move this down. The ice maker is really freaking me out. Let's see. Crop this out right quick. All right. So this is these are some other calculations, but they're have more context, more nuance to them. So here it says gasoline is sold by the liter in many countries. How many liters are required to fill a 12-gallon tank, gas tank? So what do we need to know?
The conversion factor for gallons and liters.
Yes, thank you, thank you, thank you. We need to know, we know one of our units is liters that we're looking for. We know we have a 12-gallon tank, so we need to know the conversion factor from gallons to liters, right? So can somebody Google that? I mean, we have a chart, but you can look it up real quick. Anybody got it?
See, here's the thing. When you looking up stuff like this, like conversion factors, you always got Google give you like just most precise decimal possible. So this thing
Let's have it.
yeah,
Let's have that one.
it says 1 gallon is 3.78541 liters.
So let's take 3.785. Let's take that.
All righty.
Over what? 1 gallon. Is that right?
Yes, sir.
All right. So now we can also keep in mind our units, our sig-figs. There are no prefixes, so we don't have to worry about that, right? But now we can see that the answer needs to be in 2 significant figures because this is 2 sig-figs and that's 2 sig-figs, right? And this is 4 sig-figs, right? So all we're doing now is just multiplying those 2 numbers. What do we get? We don't do any rounding or anything until we get the answer. Anybody?
After multiplying, I got 12 times 3.785 is 45.42.
This must be a truck. Can you imagine spending, how much is gas right now where you are? Somebody, anybody?
287.
Ooh, y'all doing good. 287. That's not that bad. But imagine that's a little bit, that's gonna be a little bit over 90 bucks, maybe about $95 to fill up that tank. That must be a truck or like a G-Wagon or something. But that's 45.42 gallons. We need to take that to 2 sig-figs. So we'll say that it's 45 gallons.
That should be liters, right?
Oh, yeah, sorry. We didn't liters. My bad. Because gallons cancel. You're right. Liters. 45 liters. Because the gallons here cancel. Thank you. All right. Let's go to here. It says make the conversion. And it says in three sig-figs, make the conversion the length of a soccer field, 120 meters to feet. So we need a conversion factor from what? Meters to feet, is that right? Can we do it? But there's a long way and a short way. Which way do you want to do? Let's do the long way.
Uh,
Let's do the long way. Because we have a conversion from meters to yards, don't we? Already, we talked about that the other day. So it's 120 meters times, let me change my pen, 1.09 yards per 1 meter. Let me shrink that down. Per 1 meter, is that right? So meters are going to cancel, and then I'll be left with what? Should be a little bit over 120. Anybody got it? 1.09 times 120.
130.8.
So 130.8 yards, and then times how many feet are in a yard? Now that we should remember that from like middle school or
3.
elementary school.
3.
3 feet in a yard, right? So that's 130.8 times 3 feet per 1 yard. All right, and again, this is a calls for multiple conversions. There's another conversion that you can use, but we're going to use this. All right. So somebody calculate that. What's that? That's 390. And then 24. Anybody got it?
392.4.
392.4. And this is feet. All right. And then it says 3 sig-figs. That's what we're reporting in. It's telling us to report it in 3 sig-figs. So what do we got? We just need to round that down, don't we? Or round it so that it's 3 sig-figs. So 392. Yep. Is that right?
Yes.
Mm-hmm. All right. So now let's do the next one. It says the height of Mount Kilimanjaro, 1,565 feet. It's the highest mountain in Africa. And we want to convert that into kilometers. So what do we need to do? We can go from what? Feet to meters. And then what? Meters to what?
Kilometers.
Kilometers. Very good. So let's go from feet to yards, and then yards to meters, and then meters to kilometers. Let's do that. Let's do it. The long way is better. So we have 1,900 565 feet times what? We want yards in the top, right? 1 yard over 3 feet. Yes or no? It's kind of like the one we just did, but we work in the opposite direction. Is that right?
Yes.
So let's get rid of that. So that's boom, feet cancel, and I'm left with yards. So 19,565 divided by 3. It's gonna be somewhere about a little bit over 6,000, roughly somewhere up in there. Anybody got it? And again, if you know your conversion values, you can convert between any 2 units. It doesn't matter.
We're dividing 19,565 by 3.
Yes.
I got 6,521.6 with the line over it and a 7.
So so 0.67,
Mm-hmm.
and we say that's yards, right? And we want now yards to meters. So what's the conversion? One meter. Want that in the top because we want to get rid of yards. Is 1.09 yards. Is that right? We just use that up top. All right. So somebody do that calculation. And yards are going to cancel. And then we're left with meters. You always want your discarded unit in the bottom and your desired unit in the top. Anybody? 6,521.67 divided by 1.09.
All right. I got 5,983.18.
Okay, great. That's in meters. Now we need to convert that into what? Kilometers. So 1 kilometer over 1,000 meters. What do you got? I mean, there's a short way to do this, but we're not going to do it. We want to do it this way.
I was about to say, this is the long way.
Yeah, it's the long way. It's better to go the long way. The more experience you get, the better you are. So the long way is good. We got
That don't
to.
be chemistry.
Come on, Saxton. You're doing a little bit too much complaining now.
I'm trying.
Right? We just walking this through. And in the process, how many conversion factors have we looked at? We looked at 3 different conversion factors. That's 3 times the experience you would get, you know, if you were doing it the short way, trying to do a shortcut. All right. So what do we have? 5.98318. Is that right? Time. Oh, sorry about that. Is that right?
Yes.
All right. And as far as sig-figs are concerned, it didn't give us a number. But let's go with, since we started with 2 here, let's go with 2 here. So how would we report that in 2 sig-figs?
6.0.
6.0 kilometers. Good. That's for 2 significant figures. It's a long way.
I have a quick question. Why are we going to 2 sig-figs?
Because the original length. Am I no, wrong one, my bad. I'm looking at 120. I mean, I intend to look, I'm looking here. So that's at 5 sig-figs. Let's keep it at 5 because it gave us the height and with 5 sig-figs. So let's do that. And on the exam, I'll ask you, like I know what the rules are, you know what the rules are, but I may ask you to report your answer with a certain number of sig-figs. So if we do 5, this is going to be what? 5 point what? 9832 kilometers. Is that right?
Yes.
All right. So we're going to stop here. We got a couple of more to finish. So bring it back Wednesday. We're going to finish it because the reason why this is so important is because everything that we do in subsequent chapters, there are going to be so many different calculations, and we need to master conversion factors. We need to master units. We need to master prefixes because once the roller coaster starts going down, it's going to be down for a long time. All right. So that's why we're taking our time walking through this. So we're going to finish the rest of these on Wednesday, and then we'll probably start chapter 2 on Wednesday also, which is dealing with the periodic table. All right. But these calculations are these are very vital to everything else that you're going to do, not the calculations themselves, but the process, learning how to develop a conversion factor, knowing what to put in the top, what to put in the bottom, knowing how to convert to scientific notation. All that stuff matters because there are going to be several chapters where it's all calculations, whether it is converting into moles, whether it's figuring out like the volume from the ideal gas law. Well, I mean, all these calculations are they're gonna help that stuff to make sense. All right. So don't pout too much about going the long way. We go